Class. I'm Dr. B, your chemistry teacher, and today we are going to take a look at absorbance and molar absorptivity. Okay, absorbance and molar absorptivity. These are also part of those parameters in spectroscopy you will be required to calculate. Remember that in our earlier class we had seen how we can calculate frequency and also try to calculate wave number. Okay, so again we have absorbance and molar absorptivity to take a good look at, and that reminds us of certain things we have discussed when we're looking at the principle of infrared spectroscopy and that of the UV visible spectroscopy. Now, do not forget that you have to share this class. Share this class. Please share this class with friends and colleagues, and then endeavor to tell them to subscribe to be part of what we are doing. All right. Now, do not also forget to like, to comment. You go to my Facebook page, Dr. B Chemistry Classes, and follow as well. As you share, as in to follow, you can follow in case you just got this as a prompt in your phone. You can also click the follow button and then you follow us, like and comment. Now the question here is 0.5 molar solution shows 10% transmittance. If path length is 1 cm, calculate A, the absorbance, and B, molar absorptivity. Very simple. Okay, you are carrying out a spectroscopic experiment, let's say a UV visible spectroscopy experiment, and at the end of the day, the concentration of the sample that you had used in your sample container, remember we have discussed that already, has a concentration of 0.05 molar, and then the path length of that particular container is 1 cm with a transmittance of 10%. Maybe I should remind us a little bit of what I mean here. Now, what it means that there is a light source. Okay, there is a light source that come in, and of course, where is the light source going to hit? It's going to hit into a slit that's supposed to be your entrance slit, and from the entrance slit, the light is going to hit of course your transducer. Okay, so it's going to hit your transducer. Going to hit your transducer. From your transducer is going to hit an exit slit, and from an exit slit the light is going to hit a sample container where there is a sample inside here, and from here some of the light are going to be absorbed, and then from here you are going to have the transmitted radiation, but of course here is your incident radiation. So the transmitted radiation will rather now choose to hit will hit what you call the detector, and from the detector is going to come to the screen where you have this. Okay, so this was what we had, just to remind us that what we are saying is that the concentration of this particular sample is 0.05 molar. Okay, and then the path length, the length is what is defined here as 1 cm. Okay, the length is 1 cm, concentration of this particular substance is 0.05, and the light that is transmitted, this light that is transmitted, okay, is what we have as 10%. This is what we mean. So the source of light enters an entrance slit, goes to what? A transducer, and gets an exit slit, and at this point we call the monochromator, and then the incident light hits what? Hits the sample container, and then absorption take place, transmittance move. From 10% transmittance was what the transducer detected. Sorry, the detector it detected, and then the concentration of this sample was actually 0.05 with the path length of 1 cm. Now the question is, what is the absorbance and what is the molar absorptivity? Have you finished solving it? You have not finished solving it? Alright, let us solve it together and see how it is. Now I'm going to erase this so that we can use this piece to solve the problem. Now, to solve this problem, it is simple. Remember, that for A, okay, let's say this is the solution. For A, transmittance, or rather absorbance, is equals to minus to the log of transmittance. That is the formula to calculate absorbance. Remember that we are given concentration, we are given transmittance, we are given path length. We do not need a formula that has all these if we want to transfer. If you choose to use a formula that says A is equals to this, C and L, where this is actually your molar absorptivity, concentration, and what, and your path length, how will you get your molar absorptivity? So you cannot use this formula. You rather use this one where the transmittance is given to you. And now for you to do that is simple. For us to do that, we will just say minus to the log of what? 10%. Remember that 10% is simply 10 all over 100. And this is the same thing as 0.1. Okay, so this is minus to the log of 0.1. The log of 0.1 is 1. Use your calculator and check. The log of 0.1 is 1. So you can have minus 1. So that minus 1 will cancel this minus 1 and give you what? 1. So the log of 0.1 is minus 1. Minus 1 times minus will give you plus 1. So that means that therefore our absorbance is equals to what? Is equals to 1. That is it. Our absorbance is equals to 1. It's as simple as that. So if absorbance is equals to minus log of transmittance, transmittance is given to us in percentage, convert it from percent. You have 0.1. So log of 0.1 will give you minus 1. Minus 1 times minus 1 times minus, it gives you plus 1. So the absorbance is what? Is 1. That is it. Now how about the molar absorptivity? Now for B, molar absorptivity can also be gotten from absorbance, molar absorptivity, concentration, and length, path length. If this is molar absorptivity, then molar absorptivity will be equals to what? Will be equals to absorbance all over Cl. That is, make this the subject of your formula. This will be all over this. Now for you to get the molar absorptivity, you already have the value of what? Absorbance, which is 1, concentration is 0.05, and then the path length is 1 centimeter. Should it not be in centimeter, you must convert it to centimeter. Remember what I said in our previous classes when we were talking about principle of UV visible spectroscopy. But right now it is in centimeter, so that is good. We're going to substitute these values 1, 2, and 3. Of course, this is worked already, so 1, 2, and 3 will substitute these values into this equation. So that will give us what? 1 all over, because 1 is the absorbance, C is a concentration, which is 0.05 molar, times what? Times the path length, which is 1. Do you know that 0.05 times 1 is still 0.05? Yes, it's still 0.05. So it means that our molar absorptivity will be equals to 1 all over 0.05. And if you use your calculator now and press 1 divided by 0.05, you're going to have 20. You have 20 liters per mole per what? Per centimeter. This is what you have. The mole is the liters is simply giving volume, the mole is giving you concentration, and the centimeter is giving you the path length. So you have been able to calculate the absorbance, and also you are able to calculate the molar absorptivity. You can see that the formulas that breed this are basically absorbance formulas. But you have to be technical in answering your question, because if you choose to use this absorbance formula to calculate absorbance, you have not been given molar absorptivity. So you rather go and use the formula that gives you a privilege of using transmittance, seeing transmittance was given to you. You must make use of your brain and be fast in thinking and manipulating your data to be able to arrive at math calculations or mathematical equations, as the case may be. Or you have issues in doing your calculations and arriving at the right answers. Now, I want to appreciate the fact that you are part of this class today, being able to learn how to calculate absorbance and molar absorptivity. Do not forget to share this class through the YouTube page, and then let them know that they have to subscribe as well by hitting the bell button, please, the subscribe button. And then the Facebook page, if that is where you saw this class, help to also share it and let them know that they can also tap the follow button, where the classes will come to them at their convenience. And then they should also like and do it and comment. Until next time, I remain Dr. B. It is a bye for now.